is algebra. It's simple. It's all about puzzles. Here's one for you. This plus 2 equals 5. We just have to find the number in this box. Which number, when added to 2, gives us 5? Simple. It's 3. We can say that 3 plus 2 equals 5. This thing we see here contains only numbers. This puzzle can also be asked in a different way. We can say that x plus 2 equals 5. Find x. We just used a letter in place of the box. These letters are also called as variables. Sometimes also referred to as the unknown since its values is not known to us. This is algebra. It deals with variables and unknowns and we are expected to find their value. But why use variables? Why not boxes like these? Let's assume there are 3 unknown numbers. Using shapes, we can write it as a square plus a slant square plus an empty circle plus 4 equals 7. You had to think of different shapes. Using variables, we can write it as x plus y plus z plus 4 equals 7. This was a little more convenient as compared to the previous case. But what's the real advantage of using variables? Read this short story and the question that follows. Your friend had a few chocolates with him. A bully came across, took away 5 of his chocolates, and then he had just 7 chocolates remaining with him. How many chocolates did he have before the bully came to him? This question has 40 words. Let's see if it can shorten the question a bit. Assume your friend had X chocolates with him. The bully took away 5 of his chocolates. So we subtract 5 from X. And after all this, your friend was left with 7 chocolates. This entire thing will then equal 7. Now all we have to do is find X. This entire question of 40 words can be written like this. So yes, algebra makes life simple. In the previous video, we have seen how algebra makes our life very easy. It helps us write long phrases in a very short way using variables. That's the beauty of algebra. How do we write the sum of 3 and 7 using numbers? We just write it as 3 plus 7. Let me modify the question a bit. How do we write the sum of a number and 7? Since this number is unknown, we use a variable in its place and write it as x plus 7. Both these are called expressions. As this involves only numbers, it's called a numerical expression. And because it involves variables, it's called an algebraic expression. Now look at this line. Sum of a number and 7 equals 12. Now it gets interesting. Let's break it into parts. Sum of a number and 7. It can be written as x plus 7 equals 12 can be written as equal to 12. We wrote this phrase as x plus 7 equals 12. Is this an expression? No, that's not the case. This is called an equation since it has an equal to sign. It's called so because we are equating two sides, the left-hand side and the right-hand side. What are the different parts of an equation? This is called the variable, that is, we are expected to find. And these two numbers are called constants as their value remains constant. There are also operators like addition and subtraction. So these are the important parts of an equation. Remember, the equal to sign divides the equation into two sides, the left-hand side and the right-hand side. Concepts in algebraic expressions is the concept of terms. Look at the number 4. Yes, it is a term. What about the variable x? Yes, this is also a single term. Now let's look at a couple of expressions. Like 4x, two terms are multiplied here, 4 and x. Does this mean these are two terms? No, this is just one term. What about 4 divided by x? It's one term divided by another term, and in its entirety is also one term. So when two single terms are multiplied or divided, it remains a single term. Here's another interesting expression. 4 plus x. How many terms are present in this expression? There are two terms here. This operator, which is the addition sign, separates the terms. What about 4 minus x? This also has two terms. What does this mean? It means that plus and minus separate the terms. If we have a plus sign over 4 and x, it will just separate the terms like this. Or even if we had a minus sign over 4 and x, it will separate the terms. But remember, multiplication or division do not separate the terms. Now let's analyze the term 4x. It is just one term, but it has a constant and a variable. The constant is called the coefficient of x, and this x, as we already know, is called the variable. Just remember these two things. Plus and minus separate the terms. Multiplication and division do not. In the next part of the video, we will look at a few expressions to understand the concept of terms really well. This is where we left off in the previous video. We saw that plus and minus separate the terms, and multiplication and division do not separate the terms of an expression. Let's look at a few expressions and find out how many terms they have. Here's the first expression, 4 plus x. We can see a plus sign here. It means that this expression has two terms, 4 and x. Here's the second expression, 7 minus x minus y. We have two minus signs here. It means that this expression has three terms, 7, x and y. Remember, plus and minus separate the terms. What about 7x divided by y? This expression involves multiplication and division. And as we know, they do not separate the terms. This is just one term. What is 7 in this case? It's called the coefficient of x by y, the coefficient of this. How many terms do you think are present in 4x minus y plus 7? This is interesting. 4x is just one term since it involves multiplication. Y and 7 are the other terms which are separated by a minus and a plus sign. So this expression has three terms in all, 4x, y and 7. What about 7xy plus 20y minus 3z plus 8? One term, 2, 3 and 4. Four terms in all. Each of these is one term. Here's the last expression, 8xyz. Since it involves only multiplication, this is just one single term. Even though there are three variables and a constant, this is a single term. Types of terms, we need to understand the concept of the power of variables. Let's consider two different terms. The first term is 7xy and the second one is 17x cubed y squared. Observe the first term. It has two variables, x and y. What is the power of each of these variables? The power of x is 1 and the power of y as well is 1. Now look at the powers of variables of the second term. The power of x is 3 and the power of y is 2. Both these terms have the same variables, x and y, but the powers of each of the variables are different. Let's erase this and jump to the concept of the types of terms. There are two kinds of terms, like terms and unlike terms. What is the difference between them? Two terms are like if they have the same variables with the same powers. Don't worry, we will understand this with examples. When are they unlike then? Two terms are unlike if they have different variables or same variables with different powers. Let's zoom out and understand a couple of examples. Consider two terms, say 7xy and 15xy. Are these two terms like or unlike? Remember, to know the type, we just have to look at the variables and not the constants. Both these terms have the same variables, x and y. But that is not enough to tell us if they are like or unlike. The next thing we need to compare is the power of each variable. The powers of x are the same in each term, it's 1. And yes, the powers of y in each term is also 1. As both these conditions are satisfied, we can say that they are like terms. Same variables and same powers of each variable. What about 3x squared y and 3xy cubed? Are they like or unlike? Both the terms have the same variables x and y. Now let's compare the powers of each of the variables. Let's look at the power of x first. In the first term, it's 2, and in the second, it's 1. It's not the same. Even though the variables are the same, because the powers are not equal, these are unlike terms. Observe that we do not bother to check the powers of y in each case. Remember, if the powers of one of the variables is different, the terms become unlike. What about 8xyz and 8xy? The first term has three variables, x, y, and z, and the second term has just x and y. It does not have z. Both the terms have different variables. Hence, they are unlike. Just remember these two things and you would have no problem understanding the types of terms. And what polynomials are? Let's look at the concept of terms and expressions. 14xz plus 53y minus 3. There is a plus as well as a minus sign here, which means that we have three terms, 14xz, 53y and 3. The second expression is 23x squared y minus 4y cubed. This expression has just two terms, 23x squared y and 4y cubed. Now we can move on to understanding the most important concept in algebraic expressions. It's the concept of polynomials. As you can see, the word has been colored into two parts. Poly means many and nomial means parts or terms in the case of algebraic expressions. And that's how the word polynomial comes about. There are different types of polynomials. A polynomial can be an expression with just one term, or two terms, or three terms, or maybe even a greater number of terms. All these categories come under one roof, which is the polynomial. Expressions with just one term, two terms, or three terms are given special names. An expression with one term is called monomial. An expression with two terms is called a binomial, and an expression that has three terms is called a trinomial. Mono is 1, bi is 2, and tri is 3. There is a common misconception that only an expression with more than three terms is called a polynomial. That's incorrect. All expressions which have one or more terms are called polynomials. Let's look at a few examples of each. The number 7 is a monomial. It's just one term. 4x is also a monomial. It's just one term as 4 and x are multiplied. Even 3ab squared is a monomial. And yes, all these expressions are also polynomials. An example of a binomial would be 4 plus x. The plus sign separates the terms. Another example would be 3xy minus x. An example of a trinomial would be 3 plus a plus b. It has three terms, 1, 2, and 3. Or maybe 3cd plus a plus 8. Again, let me remind you, all these examples you have seen are polynomials. And an example of the last type would be 4z plus 9 plus 3x plus y. It has 4 terms in all. So remember, a polynomial is an expression which has one or more terms. We will look at an extremely important concept related to polynomials. Think about it. There can actually be just two broad categories of polynomials. The first category, which has just one variable, and the second one, which has more than one variable. That's it. These are the only two possibilities. An example of the first type would be 6x raised to 5 plus 2x squared minus 7x plus 9. This polynomial has just one variable, which is x. An example of the second type would be 5xy cubed plus 17xy plus 9y squared plus 9. This has two variables, x and y, which makes it fall into the second category. So what about these two categories? Why did we form them? It is for the concept we will look at in this video, the degree of the polynomial. In the first category, where we have just one variable, the degree is the largest exponent of that variable. Here, 5 is the largest exponent, which tells us that the degree is 5. The degree of this polynomial is 5. Let's look at a second example in this category. 21x plus 6x cubed plus 7 plus x squared. In the first term, the degree of x is 1. In the second term, the degree of x is 3. And in the last term, it's 2. 3 becomes the largest exponent of the variable. And that's why the degree of this polynomial is 3. Is it any different in the second case? Yes, slightly different. In the second case, for each term, we add the exponents of each variable in it. How will it work out for the first example? Remember, we have to look at each term individually. Consider the first term, 5xy cubed. We had to add the exponents of each variable in it. The exponent of x is 1 and the exponent of y is 3. So for the first term, we consider the power to be 1 plus 3, which is 4. Now we come to the second term. There are two variables, x and y, and each of them have an exponent equal to 1. Adding the exponents, we consider the exponent of this term to be 1 plus 1, which equals 2. In the third term, we have just one variable. Its exponent will just be 2. And as we have no variables in the last term, its exponent will be 0. Remember, we are looking at exponents of variables. The exponent of variables of the last term is 0. And the largest of these becomes the degree. The degree of this polynomial is 4, which is the highest amongst these. Here's our last example. 7xz plus 10 plus 3z cubed y plus 19y raised to 4. We have 4 terms here. In the first term, the sum of exponents of x and z is 2. In the second case, since we have no variables, the exponent is 0. In the third term, it's 3 plus 1, which equals 4. And in the fourth term as well, the exponent is 4. 4 is the highest amongst these 4 terms. Hence, the degree of this polynomial is 4. Add these two expressions. Adding two algebraic expressions is very simple. But trust me, it's very easy to make a mistake. The first thing we should do is write this problem in a way which is very simple to understand. We write the first expression here, 5xy plus 3x cubed minus 11y squared plus 2. We have to add these two expressions. So we put a plus sign here and write the second expression as is. 7y minus 4xy plus x cubed minus 3. This looks familiar. The first step now should be to group like terms. 5xy and minus 4xy are like terms. The first group will be 5xy minus 4xy. There are two terms with x cubed as the variable part. The next group will be 3x cubed plus x cubed. The third term is minus 11y squared. There is no other term which has y squared as the variable. So we write a minus 11y squared as is. Remember to lightly strike off the terms that have already been considered. Next in line, we have 2. Minus 3 is a like term. The fourth group would be 2 minus 3. 7y is the only term that's left, so we write it here. Now we're done with the grouping. In the second step, we need to solve each group. 5xy minus 4xy equals xy. 3x cubed plus x cubed gives us 4x cubed. We write minus 11y squared here. 2 minus 3 is minus 1. And we have 7y here. Can we leave it at this point? Yes, we can, but remember, it's always a good idea to arrange the terms in the descending order of their exponents. 4x cubed will come first as the exponent is 3. These two terms have the same exponent value, so we write xy minus 11y squared next, then 7y, and last would be minus 1. These two big expressions add up to this expression with just 5 terms. Simple question. What is an identity? Now look at this equation. X plus y is equal to y plus x. No matter what value we take for x and y, this equation will always be satisfied. By satisfied, I mean the left-hand side will always equal the right-hand side. Let us try different values for x and y. Assume x equals 1 and y equals 2. We try substituting these values on the left-hand side and the right-hand side. The left-hand side will be 1 plus 2, which equals 3. We put 1 in place of x and 2 in place of y. And the right-hand side equals 2 plus 1, which also equals 3. So for these values, the equation is satisfied. The left-hand side is equal to the right-hand side. Now we assume different values for x and y and check again. Remember, this will be an identity if it is satisfied for any values of x and y. Say x equals minus 1 and y equals 3. We get the left-hand side as minus 1 plus 3, that equals 2. And the right-hand side equals 3 plus minus 1, and that also equals 2. So the equation is satisfied for these values too. No matter what values you try out, this equation will always be satisfied. These kind of equations are called identities. Now here's another question. Say PQ equals square root of PQ. To check whether this equation is an identity, we try substituting different values of P and Q in the equation. Let us assume P equals 1 and Q equals 1. The left-hand side equals 1 multiplied by 1, and that equals 1. And the right-hand side equals square root of 1 multiplied by 1, which also equals 1. So these values of P and Q satisfy this equation. So does that mean this equation is an identity? Let us try a few more values. Assume P equals 1 and Q equals 2. After we substitute these values, we get the left-hand side as 1 multiplied by 2, that equals 2. The right-hand side equals square root of 1 multiplied by 2, which equals square root of 2. So we can see that for these values of P and Q, the equation is not satisfied. Hence, this equation is not an identity. So if we have to summarize, we say that an identity is an equation that is satisfied for any values of its variables.